Hello my dear children. Today we are moving to the last lesson of ICSE 10th standard textbook, that is radioactivity. As we all know, everything in the world is made up of atoms. The structure of the atom is what gives an element its chemical and physical properties. Atoms are made up of three smaller particles: electrons, protons and neutrons. An atom consists of a nucleus at its center, surrounded by electrons which are revolving in some specific stationary shells. Electrons in different shells have different energy values. The electrons has a negative charge which is equal to minus 1.6 into 10 raised to minus 19 coulomb, and mass of electron is 9.1 into 10 raised to minus 31 kilogram. Now, the nucleus of an atom consists of protons and neutrons, which are also called nucleons. Proton has a positive charge equal to plus 1.6 into 10 raised to minus 19 coulomb, and its mass is 1.67 into 10 raised to minus 27 kilogram. The number of protons in the nucleus is called atomic number of that element, and which is denoted by the letter Z. Atom in its neutral state consists of equal number of electrons as that of protons. Neutrons are electrically neutral particles and its mass is nearly equal to that of protons. The total number of nucleons in the nucleus, that is, the total number of protons and neutrons in the nucleus, is called mass number of the element, and it is denoted by the letter A. Since electrons are having negligible mass as compared to protons and neutrons, mass of an electron is negligible as compared to that of protons. Hence, total mass of an atom can be considered to be the same as that of mass of its nucleus. The atom with its atomic number and mass number is represented like this. Hence, we can conclude atomic number is the number of charged particles in a nucleus, and mass number is the total number of nucleons. Atoms of the same element with same atomic number but different mass number are called isotopes of that element. For example, hydrogen has three isotopes, namely protium, deuterium and tritium. Each isotope in its nucleus has one proton, but protium has no neutron, deuterium has one neutron and tritium has two neutrons in the nucleus. Isotopes are of two kinds: stable isotopes, which have number of neutrons nearly equal to the number of protons in their nucleus, and unstable or radioactive isotopes, which have number of neutrons much more than number of protons in their nucleus. Unstable nucleus undergo radioactive decay. Hence, one of the main reasons for radioactivity is that a nucleus consists of more number of neutrons than that of protons. Now, atoms of different elements with same mass number but different atomic numbers are called isobars. For example, two elements, carbon 14 and nitrogen 14, are isobars since their mass number is 14 but atomic number of carbon is 6 and atomic number of nitrogen is 7. If the number of protons and neutrons get interchanged inside the nucleus, they are called mirror isobars. For example, sodium 23 and magnesium 23 are mirror isobars, since in sodium the number of proton is 11 and number of neutron is 12, while in magnesium number of proton is 12 and number of neutron is 11. Atoms having different number of protons but same number of neutrons, that is different atomic and mass number but same number of neutron, is called isotones. So in isotones, the number of electrons and protons are different but number of neutrons is same. Now let's go in detail about radioactivity. Henri Becquerel discovered the phenomena of radioactivity in 1896. Once in a dark room, he left a uranium salt placed on a photographic plate wrapped in a black paper. After some days, he was surprised to find that the photographic plate had been affected. Later on, the same observation was made with some other salts of uranium, and from these observations, he concluded that uranium and its salts by themselves emit some kinds of radiations. These radiations were called Becquerel rays. On further investigation, these radiations were found three types: positively charged, negatively charged and uncharged, which were then named as alpha, beta and gamma radiations respectively. The substances which emit these radiations were called radioactive substances, and the phenomena of spontaneous emission of radiation from the nucleus of a radioactive substance is called radioactivity. Hence, radioactivity is the spontaneous emission of alpha, beta and gamma radiation from the nucleus of an atom during their decay. Any physical change or chemical change does not change the nature of radiations emitted by the substance and its rate of decay. Hence, radioactivity is not an orbital phenomena, but it is purely a nuclear phenomena. Rutherford is the scientist who had experimentally studied the nature of radiations emitted by a radioactive substance. He found that on subjecting the radiations given out by a radioactive substance to a magnetic field in a direction perpendicular to their path, they separate out into three distinct constituents in which the magnetic field is normal to the plane of paper inwards. The radiations which turn to left is positively charged and they were called as alpha particle. Those which turn to right is negatively charged and are called as beta particle, and the radiations which pass undeviated are called as gamma particles. By the same way, if the radiations given out by a radioactive substance are subject to an electric field in the direction perpendicular to their path, they again separate into three constituents in which some radiations turn towards negative plate since they are positively charged, and some radiations turn towards positive plate due to their negative charge, and some passes undeviated since they are uncharged. The positively charged particles are called alpha particles, while negatively charged radiations are called beta particles, and the uncharged one is gamma radiations. Now let's look in detail about the properties of alpha particles, beta particles and gamma radiations. An alpha particle consists of 2 protons and 2 neutrons. Mass of an alpha particle is roughly 4 times the mass of a proton. The speed of alpha particles is in the order of 10 raised to 7 meter per second. An alpha particle strongly ionizes the gas through which it passes. An alpha particle rapidly loses its energy as it moves through a medium, and therefore its penetration power is quite small. Alpha particles are positively charged, so they are deflected by electric and magnetic fields. Alpha particles affect a photographic plate. They cause fluorescence on striking fluorescent materials. They have large kinetic energy and momentum with them. Alpha particles destroy the living cells and they cause biological damage. Alpha particles get scattered while passing through thin mica foils. Now let's look into the properties of beta particles. Beta particles are fast-moving electrons emitted from nucleus of an atom. The rest mass of beta particle is 9.1 into 10 raised to minus 31 kilogram and the charge is minus 1.6 into 10 raised to minus 19 coulomb. Beta particles are given out from the nucleus and speed of beta particle is in the order of 10 raised to 8 meter per second. Beta particles ionizes gases through which they pass. The penetrating power of beta particle is more than that of alpha particles. Beta particles are negatively charged, so they are deflected by the electric and magnetic fields. Beta particles affect photographic plate and causes fluorescence on striking fluorescent materials. Beta particles produces X-rays when they stopped by metals of high atomic number and high melting point such as tungsten. Beta particles cause greater biological damage as they easily pass through skin of our body. Now, let's look into the properties of gamma particles. Gamma radiations are electromagnetic waves like X-rays and light. The speed of gamma radiations is same as that of speed of light. The ionizing power of gamma radiations is very low. The penetrating power of gamma radiation is highest. Gamma radiations are not deflected by electric and magnetic fields. Gamma radiations affect a photographic plate. They causes fluorescence on striking fluorescent materials. Gamma radiations causes immense biological damage as they can easily pass through skin of our body. Now let's look what changes will come within the nucleus during alpha, beta and gamma emission. If an unstable nucleus contains much more neutron than number of protons, it may emit a particle containing 2 protons and 2 neutrons tightly bound together known as alpha particle. Hence, when a nucleus emits an alpha particle, 2 neutrons and 2 protons will lose from the parent nucleus. Hence, the daughter nucleus contains number of protons and neutrons 2 less than that of the original nucleus. Hence, the atomic number of the daughter nucleus will reduce by 2 and mass number will reduce by 4 during the emission of an alpha particle. For example, when a radioactive uranium nucleus emits an alpha particle, a new nucleus, thorium, is formed and the change is represented as follows. Now, when an unstable nucleus contains neutrons more than protons, a neutron may change into proton by emitting an electron. The electron given out from the nucleus at a high speed is called beta particle. So during beta emission, a neutron changes to proton in the nucleus and the change is represented as follows. Thus, in emitting a beta particle, the number of nucleons in a nucleus remains same, but the number of neutron is decreased by 1 and number of proton is increased by 1. In other words, the emission of beta particle increases the atomic number by 1, but the mass number remains same. Hence, the new nucleus formed will be one place higher in the periodic table, and the daughter nucleus is thus an isobar of the parent nucleus. For example, a radiocarbon nucleus having 14 nucleons, 6 protons and 8 neutrons emit a beta particle and changes to a new nucleus, nitrogen, having 14 nucleons, that is 7 protons and 7 neutrons. Here, the proton is increased by 1 and the neutron is decreased by 1, since one neutron has changed to proton, and the change is represented as follows. Gamma emission happens with alpha and beta emissions. It occurs when daughter or the parent nucleus is in a state of excitation. The extra energy stored in the nucleus is released as gamma radiations, and hence nucleus does not decay into a different nucleus. That is, there is no change in mass number or atomic number of the nucleus in gamma emission. So, during gamma emission, the excited nucleus releases its energy as gamma radiations and comes to a stable state. In a single radioactive decay, alpha and beta particles are never emitted simultaneously. There will be either an alpha emission or beta emission, which may be accompanied by gamma emission. That is, gamma emission can occur with both alpha and beta emissions. Even though the radiations are harmful to the living being, there are some uses for the radioisotopes. In medical field, many diseases such as cancer, leukemia, etc. are cured by radiation therapy. Salts of weak radioactive isotopes such as radiosodium chloride, radioiodine, etc. are used for diagnosis of some diseases and are called as tracers. Gamma radiations emitted by radioisotopes are used to sterilize bandages and surgery equipments. Now in scientific field, alpha particles are used as projectiles for nuclear reactions, and radioactive tracers are used in agriculture also to study the growth of plants. We also use a technique called carbon dating, which is used to determine the approximate age of ancient biological materials such as rocks and materials of archaeological importance. In industries, radioisotopes are used as fuel for atomic energy reactors. The ionizing effect of radioisotopes is used in making certain luminescent signs. Now, the radioactive fallout from nuclear power plants and other sources, and also the disposal of nuclear waste, act as sources of radiations which causes some harmful effects on the living beings. These harmful effects are categorized as short-term recoverable effects and long-term irrecoverable effects. Short-term effects include diarrhea, sore throat, loss of hair, nausea, etc. While long-term effects are leukemia, cancer, genetic disorders, etc. Since these radiations are very dangerous to the living being, we have to take some safety rules for handling the radioactive materials. People working with radioactive materials should put on special lead-lined aprons and lead gloves. They should handle the radioactive materials with long lead tongues. They should not go beyond the safety limit for each type of radiations. The radioactive materials must be kept in a thick lead containers with a very narrow opening so as to stop radiations coming out from other directions. When we establish nuclear power plants also, we have to keep some safety rules. The nuclear reactor of the power plant must be shielded with lead and steel walls. Nuclear reactor must be housed in an airtight building of strong concrete structure. There must be a backup of cooling system for reactor core. There should be a safe disposal of nuclear waste. Now, while disposing nuclear waste, we should first keep them in a thick cask of lead, and then it must be buried in specially constructed deep underground stores far from populated areas. This cask can also be buried in a useless mine, and these mines must be sealed after storing the cask. The last topic is background radiations. The background radiations are radioactive radiations to which we all are exposed even in the absence of actual radioactive sources. There are two sources of background radiations. The first one is internal source, which includes radioactive substances such as potassium 40, carbon 14 and radium present inside our body. And the second is external source, which are cosmic rays, naturally occurring radioactive elements such as radon-222 and solar radiations. It is not possible for us to keep ourselves away from background radiations, but the total background radiations from both internal and external sources do not exceed the maximum permissible dose for human safety, so we need not worry about it. Hope you all understood everything about radioactivity. Thank you and have a nice day.